All right, this is number 1 from midterm number 2. Let's go through the solution. So it says check if 2 is the solution to the equation 2b minus 4 equals 4 times the sum of b and 1 minus 12. What we need to do for this problem is it's asking us to say if b equals 2, is this equation true? If b equals 2 and the equation is true, we know that 2 is the solution. So to check, what we need to do is plug in b equals 2 to 2b minus 4 equals 4 times b plus 1 minus 12. Now, if this is a solution, then the equation will be true. If this is not a solution, then this will not be true. That is, if b is a solution, b equals 2 is a solution. So let's go ahead and see what happens if we set b equal to 2. So plugging into this equation here, I'm going to put a 2 where I see the b here and where I see the b here. When I do that, I have 2 times 2 minus 4, and I'm asking myself the question, does that equal 4 times the sum of 2 and 1 minus 12? So this is numerical expressions on either side that we should be able to evaluate. Notice that we have 4 minus 4 on the left hand side, and on the right hand side, we'll do this parentheses first, so that's 4 times 3 minus 12. On the left hand side we have 0. Does 0 equal 12 minus 12? And, it does turn out that 0 equals 0. So what is this statement telling us? The statement is telling us that, yes, b equals 2 is a solution to the equation. So this tells us that, yes, b equals 2 is the solution. Now, in the case that this is a linear equation in one variable, which it is, this is actually the only solution. Just another note there. So b equals 2 is the only solution to this equation. This is problem number 2 from midterm number 2. Let's talk about the solution. First, let's read the question. Use the distributive property and addition property of equality to solve the equation 1/2 times the sum of 6x and 4 subtracted 1/3 times the difference of 6x and 6 equals 1. So to solve this problem, notice that this is a linear equation in one variable, in the variable of x. The way that we'll solve this problem is we're going to isolate x, in this case using the distributive property and the addition property of equality. You could also choose to work this other ways. This is the way I chose to work it out. We'll begin by distributing. We'll distribute the 1/2 to the 6x, 1/2 to the 4, and 1/3 to 6x, and 1/3 to negative 6. So as I write these down, let's talk about this. We start by doing the distribution. So we 1/2 times 6x plus 1/2 times 4. Now let's see what we have here. We have a negative 1/3 times 6x there, so I'm going to have a minus. That's 1/3 times 6x. And then I have a minus and a minus. That's going to make a plus when I do this minus 1/3 times minus 6. So I'll have plus 1/3 times 6. And then you can see that I still have that equals 1 on the right-hand side. Okay, so notice that these are all actually easy multiplications to carry through, or easy divisions to carry through. All these fractions you see here, 1/2, 1/2, 1/3, 1/3, because the numbers are multiplying 2 evenly divides 6, 2 evenly divides 4, 3 evenly divides 6, 3 evenly divides 6. So this will be a little bit easier to work out. Notice that this right here is the same. 1/2 times 6 times x is the same as 6 times 1/2, which is 6 divided by 2, or 3. So this is going to be 3x right here. Similarly, 1/2 and 4, remember that's like 4 divided by 2. That's like 2. Now, we have 1/3 times 6x. Well, 6 times 1/3 is the same as 6 divided by 3. That's 2. And then we still have to multiply by x. You can see my last term over here is just 2. And I have equals 1 on my right-hand side. By combining like terms, 3x and negative 2x, you can see I'll have an x. And I have a plus 2 and a plus 2. That would give me a plus 4. If I set that equal to 1, as it's supposed to be, we can see by the addition property of equality, if we subtract 4 from either side of this equation, or from both sides of this equation, we'll have our solution. And that solution is x equals negative 3. So this is problem number 3 for midterm 2. Let's see if we can solve, or let's look at the solution to this problem. Use the addition property of equality and multiplication property of equality to solve the equation x plus 1/2 x plus 5 equals 65. So to solve this problem, notice that this is a linear equation in one variable, in the variable of x, and so we can solve this linear equation by isolating x. You're getting x by itself. The way we'll do that is first we're going to write both sides as a sum. Then we're going to move the number parts to one side, the variable parts to the other side, using by the addition property of equality. And then we'll eventually get x by itself by using the multiplication property of equality to isolate x. To begin, we should start to write both sides as a sum, and by combining like terms at any step we can. Here you see we have an x and a 1/2 x. This is actually one of the biggest problems that I saw in this question, is the combining of x and 1/2 x. So let's talk about that. How do we combine x and 1/2 x? Well, this is like, if this was x plus 2x, we could just add 1 and 2 and we'd have 3. So think about this. This is like 1 times x plus 1/2 x. So how could I do that? Well, notice that 1x is the same as 2 over 2x, right? 2 divided by 2 equals 1. So I could also write x as 2 divided by 2 times x. This is the same. And I have plus 1/2 x plus 5 equals 65. Now I write this because hopefully now we can see that these two variable terms, we want to combine these two variable terms, so we need to combine their number parts, their coefficients, and we can do that by adding these numbers. To add 2/2 and 1/2, maybe that's a little bit more clear than adding 1 and 1/2. 2/2 plus 1/2 should be 3/2. And we still have our plus 5 equals 65. By the addition property of equality, we can move that 5 over by subtracting 5. If I subtract 5 from both sides, you see I'm left with 3/2 x equals 60. And the last step here to get x by itself is to use the multiplication property of equality to multiply by the reciprocal of 3/2. And the reciprocal of 3/2 is 2/3. You can see when I do that, on the left-hand side, I'm just left with x, and that's by design because 2/3 and 3/2 are reciprocals. And on the right-hand side, we have 60 times 2/3. We could do that a number of different ways. Perhaps the easiest way is to think about this as 60 divided by 3 times 2. 60 divided by 3 is 20, and 20 times 2 is 40. So we know our solution here is x equals 40. Alright, so this is problem number 4 from midterm 2. Let's see the solution to it. So it says find the solution set for the equation 0.2x plus 0.5 times 12 minus x equals 3.6. This is a problem from 2.3, if that wasn't clear. This is a linear equation in one variable, which we can solve using the same techniques we did for the prior problems, just a little bit more complicated. In particular, this one is especially more complicated because we have these decimals. So let's go ahead and start to find the solution. Now I'm eventually going to clear out these decimals because I don't love them, but what I'm going to do first is I'm going to write both sides as a sum, because this is a way that I kind of said will work most every time you do it this way. So let's practice it that way. Let's write both sides as a sum, and then we'll clear the decimals. So if I want to write both sides as a sum, I need to basically get rid of this product with a difference, because right now this variable term and this number term are trapped together because they're both being multiplied by this 0.5. I want to break that up by distributing this 0.5 to the 12 and this 0.5 to the minus x. So notice if I do that, I would have 0.2x plus, well, what's 12 times 0.5? Let's just do that over here on the side of the board. 12 times 0.5, well, 5 times 2 is 10, carry the 1, 5 times 1 is 5, add 1 is 6, and our decimal, there's only one digit behind our decimal points in our two factors, so we know that our product should have one digit behind the decimal. We know that it's 6, so we know this right here is 6. You could also think about this, 0.5 is the same as 1/2. 1/2 times 12 is 6. Either way would work. 0.5 times negative x, hopefully you can see that that is just 0.5x, negative 0.5x, and on the right hand side we still have our 3.6. Alright, wonderful. What I'd like to do now is combine like terms, because anytime we can do that, we should do that. It makes it a lot simpler. 0.2 and negative 0.5x. What are those combined to be? Negative 0.3x. So negative 0.3x plus 6 equals 3.6. Now, this is the stage where I would probably choose to clear the fraction, although it's totally acceptable to clear the fraction in the first step or any other step after that. I'm going to clear the fraction by multiplying by 10. The way we know how to clear fractions is we basically look at the digits behind the decimal point. In this case, you can see this term has one digit behind the decimal point, and this term has one digit behind the decimal point. That means that the smallest place value we have is tenths. Or in other words, if I chose to rewrite these decimal numbers, they would have denominators of a 10, and that's why we want to multiply by a 10. Just to be sure that we know what's happening there, I'm going to rewrite these as fractions. Notice that 3/10 can be written as 3/10, or rather negative 3/10, plus 6 equals, and 36, or 3.6, or 3 6/10 can be written as 36/10. Again, either way, at this step, hopefully you can see now that if I multiply both sides by 10, I can get rid of these decimals. So if I multiply both sides by 10, well, what happens? Well, let's distribute the 10 here, the 10 here. 10 times negative 3/10 times x. This is the same as 10 times 1/10 times negative 3 times x. Or 10 divided by 10 is 1 times negative 3x. So we have negative 3x. 10 times 6, that's a little bit easier, that's just 60, equals 36/10 times 10. Think about this. This is 36 times 1/10 times 10. 10 and 1/10 are reciprocals, they multiply to 1, so we just have 36 times 1, or 36 on the right-hand side. Sweet. So if we want to get x by itself, we need to use the addition property of equality to subtract 60 from both sides. I'll do that there. So we have minus 3x plus 60. Now we have a minus 60. If we have minus 60 on the left, we better minus 60 on the right as well. And so we do. And we have minus 3x equals, now 36 minus 60, that's minus 24. And you can see the last step in this problem is to divide by negative 3. So I'm just going to do that right here. If I divide by negative 3, and divide by negative 3, you can see the solution will be x equals 8. Alright. And problem number 5 from midterm number 2. Let's talk about the solution. So the question reads, find the solution set for the equation. 3 times the difference of 4y and 1 minus 5 equals 4 times the difference of 3y and 2. So first things we should notice is that this is a linear equation in one variable. So we would expect that this would have one solution. However, there are 2 cases when this doesn't have one solution. And those 2 cases are if this equation is an identity, and that means that both sides equal each other all the time. That means that every real number is a solution. Or the other case, in which we have a contradiction, where this equation is not true, and in that case there would be no solution. So again, we would originally treat this as though this is a linear equation in one variable. Let's try to solve for that variable. And as we solve for this variable, we'll see how we might get a contradiction or identity in this case. Let's go ahead and get started. So the way we solve a problem like this is first we write both sides as a sum. Right now we have this 4y and 1, it's trapped in the product with the 3, right? Similar with this 3y and 2 product with 4. We need to distribute these numbers into our differences in order to break this up, or break up these variable and number parts. So if we do that, 3 times 4y, that's going to be 12y. 3 times minus 1, that's minus 3. I still have a minus 5. On my right-hand side, 4 times 3y is 12y. And 4 times negative 2 is negative 8. If I make this one simpler, maybe you can see at this point, but if I make this one simpler and say 12y minus 8 equals 12y minus 8, at this point, we would say that this is an identity, which means that all real numbers are a solution. So again, this is an identity, or an equation that's always true. An equation that is always true. And we know that if we have an identity, all real numbers are solutions. And this is our solution set, all real numbers. Now, again, let's talk about why that's so. Well, think about this equation here, this linear equation in one variable. If I chose a value for y, it doesn't matter because the sides would be the same. For example, if I chose y equals 0, I'd have 0 minus 8 equals 0 minus 8. Minus 8 equals minus 8, that's true. If I chose y equals 1, 12 minus 8 equals 12 minus 8, yeah, that's true, it's 4 equals 4. In any case, we know that any value we choose, it will be a solution. And we know in cases like this, all real numbers would be the solution then. Alright, this is problem number 6 from midterm 2. Let's look at the solution. It asks us to solve the formula P equals 2L plus 2W for W. If we didn't know, this is a rearranging the formula problem from 2.4. Also, this formula is the formula for the perimeter of a rectangle, given the length L and the width W. Remember, the perimeter is the sum of the side lengths of the shape. We're just adding all the side lengths together. To solve this for w, we'd solve it the same way we'd solve a linear equation in one variable for w. For example, if p and l were numbers, how would we solve for w if it was a linear equation in one variable? And that's how you could solve this problem. So notice that what's happening to w, it's being multiplied by 2, and it's also being added to 2l. So I need to basically undo this addition of the 2l and undo this multiplication of the 2 to get w by itself. The way I'm going to start with that is using the addition property of equality to minus 2l from both sides of this equation. So I'll start by writing p minus 2l equals 2l plus 2w minus 2l. You can see that leaves us with p minus 2l on the left-hand side, and on the right-hand side, we're just left with 2w. The final step we need to do to get w by itself is to isolate w using the multiplication property of equality, or in other words, multiplying by the reciprocal of 2, or dividing by 2. Multiplying by 1/2 or dividing by 2. Either way, we can see that our solution now is that w equals p minus 2l over 2. And there's our solution. Alright, this is problem number 7 from midterm 2. Let's look at the solution. So it reads, use the formula h equals vt minus 16t squared to find h when v equals 100 and t equals 2. If you care, if you remember, this is actually the equation for the height of an object thrown with speed v at time t, thrown vertically into the air. So basically what we're trying to find is if we threw with a speed of 100, now it doesn't give us a unit, but maybe like 100 meters per second, after 2 seconds, how high is the ball? This is kind of what kind of question we're asking, what kind of question we're solving. We didn't need to know all that to solve this problem though. To solve this problem, all we actually need to do is plug v equals 100 in and t equals 2 and solve for h. And what's super cool about this problem is the equations actually solve for h. So it's really just a numerical simplification problem, if you will. Either way, let's start to plug in these numbers. So pretty much we need to plug v equals 100 and t equals 2 into h equals vt minus 16t squared and solve for h, which is already done, as I said. So let's start there. So plugging in v and t. So h equals v, well v is 100, times t is 2, minus 16 times t squared, well that's 2 squared. So that's how I write it there. You can see it's already solved for h, I just need to compute what's on the right hand side. This is a numerical expression. 100 times 2, that's 200. Now we have minus 16 times 2 squared. So remember, order of operations tells us that we should do what's in parentheses first. Well, 2 is simplified. Now I should do exponents before I do multiplication. So 2 squared is 2 times 2, or is 4. So I have minus 16 times 4. Again, order of operations tells us to multiply before subtract. So let's do 4 times 16. That's going to be, well, 4 times 10 is 40, and 4 times 6 is 24. So it's going to be 64. So 200 minus 64. And you can see our solution now. 200 minus 64 is just 136. And so we know that h equals 136 is our solution. Okay, this is number 8 from midterm 2. It says 16 is 20% of what number? How can we solve this problem? Again, this is a 2.4 problem, percentage word problem. Let's see what we can do with it. So we know that problems like this, they relate 3 items, and those items are the part, the total, and the percent. In this case, we're given the part, the percent, and we're asked to find the total. But before we talk about that, let's try to identify all the key things we can from this sentence. Pull as many mathematical statements, or a mathematical statement out of this verbal statement. First, anytime we see this what number, this is like our unknown variable. This should be a key. This is almost the first step for all these problems, to figure out what you're solving for. In this case, we're solving for the total. We're just going to call it x. Let's look at some other keywords in this sentence. Is and of. We know that is should make us think of the word equals, and of should make us think of the word multiplies, or the operation multiplication. And what I'm going to do here is I can finish out this mathematical statement, if you will. 16 is 20% of what number, as 16 equals, rather than 20%, I'm going to write 0.2 as a decimal, times x, or 16 equals 0.2x. And this equation right here is an equation that can help me find that total part, or solve for x. To solve this equation, we could do maybe one of 2 things. You can just divide by 0.2 to get x by itself. If I divide by 0.2 on both sides, well, on the right-hand side, we just are left with x. How do we do 16 divided by 0.2? If that's not immediately clear, just do it the way you divide other numbers. Let's do long division. So let's do 16 divided by 0.2. However, we don't really like 16 divided by 0.2 because we have this decimal. We're dividing by a decimal. Our divisor is a decimal. And we don't like that. We can change this though by shifting the decimal points of our divisor and our dividend. So for example, if I move this decimal point here on 0.2 to the right 1, and I also move this decimal point after the 16 over 1, I can actually say that this is the same as 160 divided by 2. Now, this is a lot easier to compute, so let's do this problem actually. So as we do this, how many times does 2 go into 1? 0 times. How many times does 2 go into 16? That's 8. 16, subtract, you can see we have 0 remainders, and you can see 80 would be our solution here. So we know that x equals 80 is our solution. Now, that might be the least amount of steps way, but maybe a simpler way to see this problem is to say, well, 16 equals 0.2x. 0.2 is a fraction that I could convert. I know that 0.2 is the same as 2/10, which is the same as 1/5. Now, what would be the advantage to rewriting this as 16 equals 1/5 x? Well, the advantage of rewriting it like this is now you can see you just need to multiply both sides by 5, and maybe that's a little bit easier for you to do than this long division. So, if I multiply by the reciprocal of 1/5, which is 5, you can see here that on the right-hand side, 5 and 1/5 multiply to 1, I'm just looking at the x, and on the left-hand side, I have 5 times 16. 5 times 10 is 50, and 5 times 6 is 30. 50 plus 30 is 80. So you can see I'm going to have the same solution either way. X equals 80. And this is in total saying that 16 is 20% of 80. Or that 16 divided by 80 equals 20%. Part total percent.
Dude, if we're going to do like Christmas lights and stuff.
Alright, this is problem number 9 from midterm number 2. Let's look at its solution. So, it says, check if the ordered pairs -1, -2, 0, -1, and 1, 2 are solutions to the equation x minus y equals 1. So let's just step back and see what we're looking at here. So what type of equation is this? This equation is a linear equation in 2 variables. We know that solutions to a linear equation in 2 variables, they're ordered pairs. So these look like the solutions. That's good, so that makes sense. We also know that there's an infinite number of ordered pair solutions. And if we graph those infinite ordered pairs, it would look like a line in a plot. That's a little bit beyond the scope of this question, but let's look at what this question's asking us then. It's asking us if these ordered pairs, -1, -2, 0, -1, and 1, 2, are solutions to x minus y equals 1. Or in other words, when x equals -1 and y equals -2, is this equation true? Similarly, when x equals 0, when y equals -1, is this equation true? And finally, when x equals 1 and y equals 2, is this equation true? Now, when these equations are true, we know that these ordered pairs are solutions. And when these equations are not true, we know that that solution, or that ordered pair is not a solution. So what we're going to do is we're going to step by step, we're going to plug in basically the values for each ordered pair one at a time, and we're going to see if each ordered pair is a solution. So let's start with -1, -2. So -1, -2, is it a solution? Well, that means x equals -1 and y equals -2. Let's plug that into x minus y equals 1. So x, -1, minus y, well, minus and minus 2, does this equal 1? This is the question. And again, if this is yes, this means that -1, -2 is a solution. Well, -1 minus and minus 2, does that equal 1? Well, that's -1 plus 2, does that equal 1? And yeah, you know, that does equal 1. So we know that this right here, -1, 2, is a solution. Yes. Solution. I'm probably not going to have space to write the solution, so I'm going to erase it. Let's look at our next ordered pair. Again, so this is just saying that x equals -1, y equals -2. This is a solution, or this is a point on our line x minus y equals 1. If we wanted to look at our next guy, we have 0, negative 1. Well, what do we do there? This, again, is like x equals 0, y equals negative 1. Is the equation true? Well, if we plug that in, we're going to have 0 minus a minus 1. Does that equal 1? And you know what? That also works out. So we know that 0, negative 1 is a solution. Cool. How about this last guy? 1, 2. Well, 1, 2. This again is telling us that x equals 1, y equals 2. Does the equation x minus y equal 1 hold? Well, this says that 1 minus 2 equals 1. Is that true? Well, 1 minus 2 is minus 1. Does that equal 1? And that does not equal 1. We know that's not true. That's a contradiction. Now, if that's the case, we know that this is not a solution. No. So here we have our answers that negative 1, negative 2 is a solution. 0, negative 1 is a solution. 1, 2 is not a solution. All right, this is problem number 10 from midterm 2. Let's see what we can do with it. On the same coordinate axes, plot and label the ordered pairs negative 1, negative 2, 0, negative 1, and 1, 2. And the solution set to the equation x minus y equals 1. So let's talk about these. Ordered pairs, if we want to plot an ordered pair, this is going to represent a point, right? So we're going to plot the ordered pair, so we're going to plot 3 points. And we're also going to plot the solution set to the equation, to the linear equation in 2 variables. Now the solution set to a linear equation in 2 variables is a line. So what is this question asking us? To plot 3 dots and a line. Okay, how are we going to do that? Let's talk about that. Well, this actually kind of goes along with problem number 9, because in problem number 9, we saw that this first ordered pair and this second ordered pair are solutions, right? Now, why does that help? Again, solution, to x minus y equals 1. We saw this in problem number 9. Why is that helpful? Because we know that these ordered pair solutions correspond to points in the rectangular coordinate system that we could plot, and by putting a line between these 2 points, we can see the total solution set for x minus y equals 1. So to do this, what we need to do, we need to start plotting points and plotting lines. We need to have a coordinate axis, or a rectangular coordinate system. So I'll start by making coordinate axes. I'm going to call my horizontal axis here my x-axis. I'm going to call my vertical axis here my y-axis. And so now, by doing so, these first numbers represent x values and these second numbers represent y values. I'm going to increment up to 2 because the greatest absolute value of all these numbers is 2. I have only whole numbers, which just makes it nice. I'm not going to increment by anything special. Alright, so you can see I have labeled up to 2 in every direction on my coordinate axes, and I can start to plot these points. If I want to plot the point negative 1, negative 2, let's start there. So that's negative 1 in the x direction and negative 2 in the y direction. That'll put me right down there. And so I'll put this is negative 1, negative 2. Where's another point I can plot? Well, how about 0, negative 1? That's 0 in the horizontal direction and negative 1 in the vertical direction. So you can see that point is right here. This point is 0, negative 1. And also the point 1, 2. And I'm going to just do a red for that one. 1, 2. So 1, 2. Guys right over here. Okay. Now the reason I did that in red is because we know that this is not a solution to x minus y equals 1. And so we know that it's not going to be on the line. But we do know that these first 2 ordered pairs are solutions, so these points will be on the line. And in particular, these points can actually determine our line. So let's determine our line right here. And we can just draw. You can see that this is the solution set. So the way that we plot all these points, notice that I've labeled my ordered pairs, and to label my solution set to x minus y equals 1, I can just write x minus y equals 1 on that line. And this means that this line here represents the solution set to the equation x minus y equals 1. Alright, this is problem number 11 from midterm 2. Let's see its solution. So it says find 2 solutions to the equation x minus 3y equals 6, then plot the solution to the equation. So first things we should know, or should notice, is that this equation here, x minus 3y equals 6, this is a linear equation in 2 variables. We know that solutions to linear equations in 2 variables are ordered pairs. And we also know that there's an infinite number of ordered pair solutions. We know that the solution set this infinite set of ordered pairs can be plotted. And when we plot this solution set, those infinite number of ordered pairs represent an infinite number of points that make a line on a graph. So what we're going to do here is we're going to find two solutions first by choosing an x and finding a y, or choosing a y and finding an x. And then we're going to plot the points that correspond to those solutions on a plot, and then finally plot a line through those points. Let's go ahead and do that together. And we'll start by finding two solutions to the equation x minus 3y equals 6. Now, you can choose a lot of different numbers. I'm going to choose some of the easier numbers first. I'm going to say if x equals 0 and if y equals 0. These are the numbers I'm going to choose. I'm going to try to choose these almost every time because, you know, they're pretty dang easy to choose. So if x equals 0, then 0 minus 3y equals 6, or minus 3y equals 6, or if I divide both sides by minus 3, y equals minus 2. So one solution is 0, comma, negative 2. This is a solution. Let's look at another solution. If y equals 0, then x minus 3 times 0 equals 6, or x equals 6. So another solution is 6, comma 0. Great. So we found two solutions now. Now this is awesome because we can plot basically the points that correspond to the coordinates 0, negative 2, and 6, 0. And by plotting these 2 points, putting a line between them, we can see the total solution set to this equation. So what I'll do now is I'll put my coordinate axes in. Notice the greatest absolute value in any numbers I see here is 6. So I'm going to increment everything to 6. There's no fraction, so I can increment by whole numbers. Have a little bit smaller graph over here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, let's go ahead and plot some points. So the first point that we need to plot is 0, comma, negative 2. So that's 0 in the x direction and negative 2 in the y direction. Again, I'm going to make my vertical axis my y-axis and my horizontal axis my x-axis. Okay, so I can plot these points again. 0, negative 2. That's right down here. And 6, comma 0. That's 6 in the horizontal direction to the right, and 0 in the y direction. That's right about there. This is 6, comma 0. And I can see the total solutions by putting a line through these points. Oops, that's not the straightest of lines, but it's supposed to be. And we can see that basically all the solutions to the equation x minus 3y equals 6 sit on this line. And in particular, we can see two of the solutions that sit on the line, 0, comma, negative 2, and 6, comma 0. And they're labeled on this plot here. This is the final problem from midterm number 2. It says plot and label the graph for each equation below on the same coordinate axes. So we have 3 equations we want to graph. We have y equals 1, x equals 3, and y equals 2/5 x. So let's talk about these as we go along. Let's start with this first one. Y equals 1. What type of an equation is that? That is a linear equation in one variable, but we're actually treating it as a linear equation in 2 variables. So we're thinking about this as almost 0x plus y equals 1. Now we know that any equation that has a y equals 1, basically this means that x can be anything because we're going to multiply x by 0 and that's just going to be 0. So in a way, this means that x can be anything and y must be 1. So again, this is like x anything, y equal 1. Now, in any case, there's a name for these types of lines, and the name for these types of lines are horizontal lines. Let's have a similar discussion for x equals 3. X equals 3, this is an equation that we could write as x plus 0y equals 3. And that's really how we're treating this problem. Because again, this is another linear equation in one variable, but we're about to plot it on coordinate axes. We're about to plot it in 2 space. So we kind of have to think about it as a linear equation in 2 variables with this 0 coefficient for the y. But again, we know this is not a linear equation in 2 variables because we know that we can't have a coefficient of 0 on y or a coefficient of 0 on the x because, like I said, these will become linear equations in one variable. Either way. What does this mean, x equals 3? This means that y can be anything but x must be 3. And in either case, there is a name for these types of lines, and these types of lines are vertical lines. So remember, horizontal runs like the horizon, left and right, and vertical is up and down. So we know these two special lines is a horizontal line and a vertical line, and it meets these stipulations where the coordinate of the y is 1 and the coordinate of x is 3 for each case respectively. However, how do we plot this final linear equation in two variables? Y equals 2/5 times x. Well, this is like maybe the previous problem. If we have a linear equation in two variables, we can find two solutions, plot those two solutions, and put a line through those solutions to see the total solution set to this on a graph. So let's do that first by choosing maybe x's and y's that would work. Now the x's and y's, I'm going to choose two x values. I'm going to choose x equals 0, and then I'm going to choose x equals 5/2. The reason I do that is because 2/5 times 0 is easy, and 2/5 times 5/2 is easy. So let's go ahead and do that. Let's start. If x equals 0, then y equals 2/5 times 0, or y equals 0. So one solution is 0, 0. Now, recall that anytime we have a linear equation in two variables and there's no numerical terms, there's no number terms, see there's only terms with x and terms with y, this is going to always have the solution 0, 0, and it's going to pass through the origin. Remember, because 0, 0 is the coordinate for the origin. This is just a special case, just notice that as we're working this. So I chose one solution, let's find another solution. What if I do if x equals, and I told you I wanted to do 5/2. 5/2 would have been just as good as 1. Either way you could solve this. I'm going to do 5/2, and if x equals 5/2, then y equals 2/5 times 5/2, or y equals 1. So I know another solution is 5/2. Another solution is 5/2, comma 1. And again, that's just another solution. Okay, so again, why did we even find these two solutions? Because these two solutions correspond to two spots, the origin and 5/2, comma 1. If we plot those points, put a line through it, this will be the solution set for y equals 2/5 x. So putting it all together, we can plot these points. I'm just going to erase some of the things that we don't really need, so we can have some space to write our coordinate axes up and plot our points. So let's make it right here. There's my vertical axis. There's my horizontal axis. I'll call my vertical axis my y-axis, and my horizontal axis my x-axis. Now, how should I label these? Well, look at some of the numbers I'm working with. Well, the greatest number that I have for all of these is 3. And I should increment by halves because I have this 5/2 here. Remember, 5/2 is about 2.5. So what I'm going to do is I'll label up to 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And I'm going to give them half marks too, so we can see all those halves. Now that I've labeled my coordinate axes in such a way that all these are very easy to plot, let's start to plot some of these lines here. So y equals 1. Again, y equals 1, this is a horizontal line, right? So it runs along the horizon from left to right, and it says that x can be anything and y must be 1. Well, notice that line is just this line here. Now I'm going to be sure to label that as y equals 1. Great, so I have one line pointed, one solution set pointed. So you can see solutions to this are y equals 1 and x equals any number. So blank comma 1 will be a solution to any of y equals 1. How about x equals 3? Well, x equals 3, this is where y can be anything, but x has to be 3. So if I go to x equals 3 and y equals anything, the line that corresponds to those solutions is right here. Okay? And now finally we need to plot our linear equation in two variables. That's a diagonal line and not a horizontal or vertical line. And we can do that by plotting both these points and putting a line through them. So first we'll start with 0, 0. That's pretty easy to find. That's the origin. Then 5/2, comma 1. This is like 2.5, comma 1. So 5/2 in the x direction, 1/2, 2/2, 3/2, 4/2, 5/2, and 1 in the y direction. So that'll put me right about there. Another solution, it turns out, is if you plug in -5/2, then you'd have -1. So I'm just going to put that guy right there as well. So and also write up what these are. This is 0, 0. This is 5 halves, comma 1. This is negative 5 halves, comma negative 1. Just so we can see a couple solutions, and we could plot that line right there, that solution set. And this is the solution set for y equals 2/5 x. And so now you can see all the solutions to y equals 2/5 x, all the solutions to x equals 3, and all the solutions to y equals 1 on this graph. And they're just represented by those lines.